Hello students, welcome back to the lecture series on discrete mathematics. We are learning binary relation and this is video part 3. In this video we are going to learn the digraphs, matrix representation and composition of relations. So let us go to the definition of digraphs first. Digraph, or you may call it directed graph of relation R. Let R be a relation defined on a finite set A which contains n number of elements. We denote the elements of A by dots or small circles called vertices. The singular term is vertex. If AI is related to AJ, means if ith element of the set A is related to the jth member, draw a directed line from vertex AI to AJ, and we are going to call it a directed edge. This diagram obtained is called the directed graph or the digraph of the relation R. Let us see this by means of an example. If A is a set which contains 5 elements, 1, 2, 3 and 4, 5, we are given the relation R. Let us see the relation 1, that 1, 1. So you can have the edges from 1 to 1. That means that is going to be the loop at 1, starting from 1 to 1. Then 1, 3. Then we have a directed edge from vertex 1 to vertex 3. The order of the vertices could be anything. You can plot them on the page as per your wish or as per your convenience. Then we have 2, 3. Then edge from 2 to 3. Then 2, 5, 3, 1, 3, 2, 3, 5. At 4, 4 we have a loop. At 5, 1, that means an edge from 5 to 1 and the 5, 4. So even if the relation is not given and you are just given the digraph of the relation R, you will be able to write the relation in the form of order pairs by looking at the digraph itself. So you can see from the diagram that 1 to 5 and 5 to 1, there are two edges going from 1 to 5 and 5 to 1. That means both of them are related to each other. We have loops at 1 and 4. 3 and 4 are not related since there is no edge from 3 to 4. So this way we can talk about the relation if the digraph is given. So that is just the another representation of the relation. The next is matrix representation of the relation. So this may be from the set A to A itself or a set A to B, another set. R is the relation given. We are going to denote the matrix by MR. Now how we are going to write the matrices? If AI is related to BJ, that means ith member of the set A is related to jth member of the set B, where I running from 1 to M and J running from 1 to N, then the ith entry of the matrix will be 1, otherwise 0. So order of the matrix is M by N. The matrix relation may also be called adjacency matrix of relation R from A to B. If R is a relation on a set A, then MR is a square matrix because the relation will be a subset of A cross A, and therefore the order of the matrix will be N by N if A contains n number of elements. Let us see the example. For example, two sets are given here. A contains 1, 2, 3 and B is ABC. The relation R is given as 1A, 2A, 2C, 3A, 3B. And then the matrix of the relation R will be the rows you consider as the elements of the set A and the columns you consider as elements of the set B. Then since 1 is related to A, the 1th entry, first row, first column entry will be 1. Then for 2A, second row, first column entry will be 1. For 2C, second row, third column entry will be 1. For 3A, third row, first column entry will be 1. And for 3B, third row, second entry will be 1. The rest of the entries will be 0 and it shows that there is no relation. So here also, if the matrix of the relation R is given, we can write the relation in the form of order pairs. And if the order pairs are given, we can write the matrix. Another example from set A to B, where A contains 3 elements and B contains 4 elements. So matrix will be of order 3 rows and 4 columns. So we have A1, A2, B3, C1 and C4. So accordingly, first row first column, first row second column, second row third column, third row first column and third row fourth column entry will be 1 and the rest of the entries will be 0. In the example number 2, the relation is from set A to A itself. So we have matrix of order 4 by 4 and you can see that accordingly we have written ones and zeros. If you observe the last row of the matrix of relation, we see that it is a complete 0. That means the last member of the set A is not related to anything. That means Pune. There is nothing from Pune, the flight. There is no flight from Pune to any of the city. So this way also we can understand the actual relation or the real life situation. Now let's move to the composition of relation. Composition of relation means if R is a relation from set A to set B and S is another relation from set B to set C, then the composition of R and S is a relation from A to C and it contains order pairs A, C, where A belongs to A and C belongs to C, for which there exists a B belongs to B such that AB belongs to set R and BC belongs to set S. It is denoted by S composed with R. The figure is given below. The set A is the first set, B is the intermediate and C is the last set. R is the relation from A to B, S is the relation from B to C. Only if we have a member going from A to B and if that same member is having image in set C, then we have the relation from A to C. Let us understand this by means of an example. In the example ABC, we have ABCD in A, B is 1, 2, 3, 4, 5, C is XY. So relation R is from A to B as A1, A3, B3, B4, C5, D2, D4. S is a relation from B to C, 1x, 2y, 3x, 4y. So S composed with R. How we are going to write the S composition with R? Since A is related to 1 in R and 1 is related to X in S, A will be related to X in the composition of relation. Same way, A is related to 3 and 3 is related to X. We again have A related to X, which we have already considered. Now the third member of R is B3. B is related to 3 and 3 is related to X in R. Therefore, B is related to X. B is related to 4 and 4 is related to Y. Then B is also related to Y. C is related to 5. Since 5 is not related to any of the member of the set C, we cannot consider the relation. D is related to 2, 2 related to Y, then D is related to Y. D is related to 4 and 4 is again related to Y, so we have the order pair DY only. So this way S composed with R is written. You can consider the example 2 also. In the example number 2 again it is from A to A itself. So R1 composed with R2 will be Delhi to Kolkata, Kolkata to Mumbai and Mumbai to Kolkata. We can also consider the composition by means of the matrix of the relation. We just have to use the following rules. If we have 0, 1, we are going to take the 0. If it is 1, 1, we are going to take 1. For 0 plus 0, 0, 0 plus 1, 1, 1 plus 1, 1. If we have matrix of representation for relation S and R, we can find the matrix of relation for the composition relation S composed with R directly without finding the order pairs, directly by means of the matrix. Thank you. We will continue in the next lecture.